Hello students, we were discussing different kind of the generation mechanism of different kind of the codes that are utilized for the space spectrum communication systems. Today in the continuation of our last two module, today we will discuss about the gold and the Kasami codes, their generation process and the characteristics. Remember, we have already discussed about the choice of the code will be based on the autocorrelation and the cross correlation property of the codes, because we have understood that either the codes will be utilized for the specific specific delay estimation or specific localization positioning, where the autocorrelation peak is of prime importance, and otherwise it will be utilized for separating the multiple users in a code division multiple access kind of the scenario, where cross correlation property between the codes will be of very important property that should be that will govern the choice of the typical kind of a code. So, we are really looking for the codes who are having the very low cross correlation properties, because in a wireless communication scenario multipath delays cannot be avoided. So, two codes will never be synchronized, and only the orthogonality between the code set is not sufficient to prevail the interference between the code sets. And now we are talking about the kind of the code, gold code, we are with the understanding that it will help us to realize very better actually autocross correlation properties. Gold codes we obtain by combining the specific pair of the M sequences. Let us start with the pair of the M sequence C and C prime. Remember, the pair of the M sequence, or not all the pair of the M sequence, can help you to generate the gold code. The typical pair of the M sequence that will be helpful for generating the gold sequences are called always the preferred pairs of the M sequence. These preferred pairs of the M sequences are chosen in such a way that it finally leads to a very good cross correlation in the resulting gold codes. So, as the target is always the cross correlation, reducing the cross correlation further than the code that we have already discussed. For example, if we are starting with the ML sequence, so we are demanding the cross correlation property to be going down compared to ML, compared to Wald-Schrader mode, correct. So, let us see whether gold can give us that or not. The preferred pairs of this M sequence, they have the different autocorrelation property than the generated gold sequence, definitely it should be. The set will be generated like this. Given this pair of C and C prime, we will go ahead with a modulo 2 operation of C with a capital M circularly shifted version of C prime, and hence the generated gold code will be consisting of C, C prime and mod 2 operation of C with circularly shifted version of C prime. So, I am writing it as a tilde. So, this circularly shifted version of C prime, the way you are shifting it is the mu. So, if the capital M numbers of the, if you start with a length of capital M, and then it will be generated of M length gold code, the way you will be generating that M length gold code, you will be having at basically actually 7 length 7 M plus 2 number of the codes available inside that set, and if you include the original 2 preferred pairs inside that gold code. So, we can write in another way, the generated gold code is written like this. This generation mechanism we will discuss later in the next slide. Let us understand now that if tau is the generated gold code, and then it will be written like this. C0 is the first code, C1 is the second, C2, like that you will be getting Cm plus 1 code, where C0 is basically the one of the paired code chosen from ML sequence. Cm plus 1 is the another pair code chosen from ML sequence, and each of these codes are generated by modulo 2 bit by bit modulo 2 operation of code C with the circularly shifted version of C prime. This circular shifting can go from 1 to capital M. So, we will see in the figure 1 in the next slide the way actually the code is actually generated in the circuit, and we will start with a capital M value. Length of the value is equal to 7. So, we have chosen a ML sequence. We have chosen a ML sequence, and the pair is C prime, and both of them are having the same length. Here the length chosen we are starting with is with 7 also, and the resulting the code number of the codes that we will be ending up with is equal to 9. So, the length of the code which we started is equal to 2, length is equal to 7. We started with a pair of the ML sequence code. The length of the gold code will be also 7, but such 7 length code we will get equal to number 9. So, 9 codes, gold codes we will be generating, each of them are having a length of 7, and the paired codes who are helping us, paired codes of the ML sequence who are helping us to generate this code, they are also having a length of equal to 7. Concerning the decrease of the auto and the cross correlation function of the gold, prove the following propositions, that the preferred sequences that are chosen to generate the gold codes, they will have a 3 valued cross correlation function. Such you choose a sequence in such a way that you will end up with a gold code, and that gold code will show you the 3 stages of the cross correlation values. They are like this: one will be minus 1 by m, another will be minus t of this function m, the third will be t of function f minus 2. But this T m he will decrease at the rate of 2 by square root of m for the large value of even value of capital M, and if m is equal to large odd given by 2 to the power small m minus 1, then the decrement of this T m will be given by square root of 2 by m. So, the values with which you are ending up the cross correlation values, they are minus 1 by m, minus t of m, and t of m minus 2. So, this depending on whether the value of the capital M, the length you are choosing is even or odd, large even or large odd, you will be getting actually 3 different set of the autocorrelation cross correlation values. So, this cross correlation function that we are finally ending up with, we can see that they are far below than the cross correlation values of the Walsh-Hadamard code that we have earlier discussed, and as well as the ML sequence codes that we have already discussed. So, with respect to the cross correlation values, gold codes are really very good. Even if I see the autocorrelation value of this gold code, the autocorrelation value is also very nice. It is though actually the rate at which the autocorrelation decreases, this is really high compared to the Walsh code, but still the value of the autocorrelation peak is much higher than the Walsh-Hadamard code. So, the way we will generate the gold code is like this. So, there are 2 different ML sequence generation process who is suppose generating the these are the 2 structure of the LFSR who is generating the ML sequences, and the ML sequences are here we are denoting those ML sequences as C and C prime, and the final gold code will be generated by the bit by bit modulo 2 operation of this C and circularly shifted version of this C prime. The circularly shifted version we can easily create by changing the initial situation. Okay. So, we will be keeping on changing the initialization of this LFSR I mean all the memory stages, M stage values, and for each and every stages the bit that will be generated here will be giving one kind of the new codes associated with it. Say for if I consider that 00 C8 code is generated for 000 situation, then once you are loading it, you will be not getting, it is an XOR operation going on. So, once all of them are 0, so you will be continuously getting all the values that are stored here coming out, and you will be generating that you will be generating the first C0 code. For C8 actually we will be taking the output from here directly, because that is a direct value C1, that is a direct value C prime. So, one value is the only one value is the C0 original one, another will be the start value of the C8. C8 is the original value of the another pair of the ML code, and remaining part all the C1 to C7 you are generating bit by bit multiplication of this C0 with that circularly shifted version of my C8. So, you can check it also. Suppose if I circulate it will be 0 in the first stage. So, 0 XOR 1 will be giving me the 1. So, next is 0 XOR 1 again will be giving me the 1 like that, and then 1 with XOR with 1 will give me 0. So, like that the C1 is generating. For C2 to generate we have to circularly shift it once more, and then you map and you try to do the bit by bit XOR operation, you will see that C2 is generated. Please check at home all the generation process of all the codes and check whether you can generate all the codes I have reported here to understand the way the gold code is generated. We were discussing actually the few properties of the gold code, and we have understood that gold code can give us very nice cross correlation properties, and the value of the cross correlation peaks are very low. So, see, whenever you are getting the cross correlation peaks, if its value is really low compared to the close to the noise level, then also actually you can, it is good actually, because you can compare the interference close to the noise level and it can be discarded, and it can have a minimal effect on the detection process of the original data. So, in that sense actually, even if we can select a code in a multi-user scenario where the cross correlation properties are very close, very it is boiling down towards a very low value, and we are giving very low value peak value of the cross correlation low value of the cross correlation peaks, then this kind of the code is always preferable for a multi-user kind of scenario. And good autocorrelation property, as I understand, for my own understanding, for my own detection, for my intended kind of the reception, I need a very high or very good autocorrelation peaks. So, gold is only code who can do justice for the both. I mean, who can give you reasonably good amount of the autocorrelation peaks and reasonably less amount of the cross correlation peaks. That is why the name is gold. This is the only code available where you can get a very good cross correlation, both cross correlation and autocorrelation, both you can give very nice values, which is very rare. Usually we can get any other codes, if you whatever I have shown in the series, you will get either cross correlation value very nice or the autocorrelation value very nice. Gold is the only code where both justice to both is done. And as though we are generating the gold code from two M sequence code, because C and C prime both whatever we have started with, both are the ML codes. But remember, after combination, the ML properties, this they are no more. The the way the gold code is generated after the generation of the gold codes, they are no more actually are M sequences. So, you can never see actually the property of M sequence inside the gold code in that sense, the combined code in a set. And it should be mentioned that the first set of the gold codes that we have seen in the earlier slide, they will have the cross correlation value. The first 8 gold codes that we have a even and optimal cross correlations, and for all those 8 gold codes you will have always the value cross correlation value is equal to -1 by m, which is -1 by 7. It can be proved actually, and hence if I add a 0 to each of them, if I pad 0 to each of them, so very nicely you will get, if I pad 0 to each of them, I will get 8 length codes. So, it is so nice actually, and all of them will show you the orthogonality. So, we generated first the 7 length codes, and as the first 8 codes generated like this way, first 8 codes only, not the ninth one, always show the cross correlation property is equal to -1 by capital M. Here it will be -1 by 9. So, if I pad the zeros to each of them, their orthogonality prevails, And the good part is that now you are getting the 8 different codes of length 8. So, now see in the OVSF we have seen that in order to vary the data rate, you need the different amount of the spreading factor for the codes, where from you will generate the child codes. So, you can actually generate, you can pick up the 7th length code, gold code as a mother of this OVSF code, or 8th length code to generate the separate set of the OVSF code. So, gold codes can be nicely utilized as a mother or the parents of generation of the OVSF codes in that sense, because generating a multiple set of the orthogonal codes by simply adding the zeros, that nice property no other code will give you. Compared to the Walsh-Hadamard code, we will see that they are having the far better autocorrelation property. So, the gold codes are better in terms of autocorrelation from ML as well as your Walsh-Hadamard. They are better in the cross correlation property compared to the Walsh-Hadamard as well as ML. And with that gold codes, before comparing the gold codes with all of them, the number of the codes that we can generate, the autocorrelation, cross correlation properties and their availabilities and all. Let us finish off the series first. The last family is the Kasami code. Kasami code, even though gold code could improve the cross correlation peak values compared to the ML and Walsh-Hadamard, people tried to further lower the cross correlation property. In that search process, they designed the Kasami code, where the cross correlation function could be lowered even down compared to the gold codes. Here the cross correlation decreases as 1 by m for large value of the m, where this capital M is given by 2 to the power small m minus 1, and this is the length of the Kasami code also. And these are again derived from the M sequence. So, ML sequence or M sequences are the mother of all the other code generation, and this degree M, which always corresponds to be even number. We will take an example and see how the Kasami code is constructed. So, if small m is equal to 2 to the power k, so this guy will be 2 to the power small m minus 1 given by to small m minus 1, and then hence 2 to the power 2 k minus 1 can be further constructed. It can be further actually factorized by 2 to the power k minus 1 into 2 to the power k plus 1, where my k value is equal to m by 2. So, the way the sequence will be generated is like this. You start with a M sequence C0, and then correspondingly decimate the sequence CD. You generate the decimate sequence CD by taking the every dth chip from this C0, where your D will be given as 2 to the power k plus 1 for Kasami code generation, and repeat this 2 to the power k minus 1 chips for 2 to the power k plus 1 times. It is hard to understand. So, let us take an example. Suppose k is equal to 2. So, the value of small m is equal to 2 into k, which is equal to 4. Now, the length capital M is supposed to be 2 to the power 4 minus 1 is equal to 15. So, I have started with a M sequence of length 15 also. So, suppose C0 is having 15 chips or 15 bits inside, and where actually the number I am going, some number is plus and minus only, but I am having 15 such values, 1 to 15 such values I am having. And then the way I am choosing the dth chip is such that the D is equal to 2 to the power k plus 1. If my k value is equal to 2, then the value of D will be 5. So, every fifth chip you pick up. So, now chip number 5, chip number 10, chip number 15, these 3 will be picked up, and once they are picked up, then you have the Kasami code CD will be generated by repeating each of this chip how many times? 2 to the power k plus 1 time. So, 2 to the power k plus 1 means again value is equal to 5. So, I have picked the 5th chip and then I will repeat the 5th chip 5 times. If the 5th chip value is equal to say plus 1, so I will repeat the 5th chip 5 times. Okay. Then I will pick up the 10th chip because d value is equal to 5. So, first the value will be picked up is the 5th chip, then you pick up the 10th chip, and if the 10th chip value is say equal to minus 1. So, that value will be repeated 5 times. Suppose the last value is the 15. So, then again you pick up, if it is again supposed to be minus 1, then I will repeat again this value 5 times. So, this is my generated Kasami code finally. So, this is the way I am generating the code, but remember whatever the how many number of the chips d values you will be able to get is always 2 to the power k minus 1 chips, like this you will get, and each of these chip will be repeated first 5 times to generate your Kasami code. So, the length of the code will be equal to your length of the sequence that length of the ML sequence or M sequence with which you started, because see here also you are having a length equal to 15, but its period will be only 3. I mean the 2 to the power k minus 1, it will be the period by which actually you are by which actually the code will be repeated. And the set of the Kasami code is also constructed using the same kind of the circuit design that we have shown for the gold code generation, and there you will be generating the C0. C0 is your own code. So, ML sequence from where you are starting, and you do the modulo to sum of the C0 and C0 and all the modulo to sum of the C0 and all 2 to the power k minus 1 cyclically shifted version of this CD. So, C0 and the 2 to the power k minus 1 cyclically shifted value of this CD. So, you first construct CD from C0 the way explained, and then you take the cyclically shifted version of this CD, and then you do the bit by bit modulo 2 operation with your C0 to generate the Kasami code. And that is the way I can generate a set of the Kasami code. Last slide talked about the generation of one such Kasami code, and if I wish to have a set of such kind of the Kasami codes, so then you have to move the CD by cyclic shifted way and then keep on doing the modulo 2 operation with your C0 to generate the set. So, if I compare now the gold code and the Kasami code cross correlation values, you will see that the peak values of the cross correlation is far lower than the Kasami code, whereas the cross correlation function of the gold code takes the lowest possible value is equal to minus 1 by m most of the time. Here it is not that. And moreover, if I compare the number of the codes available in the gold as well as in the Kasami, you will find that the gold codes are much more available compared to the Kasami codes. We will see a nice example and the comparison in the next slide, where we will see that compare the number of the codes available in between M sequence, gold code and Kasami code, and their most important property where we are interested in is peak cross correlation value and where we are standing. Let us first start the comparison over the number of the codes available. So, if I am increasing the polynomial degree small m and then I will check the number of the codes available. So, if I increase it, remember the M sequence codes are easily available and they go with the increase of the polynomial degree of small m, you can reach approximately with the code with the polynomial value of 12, you can reach up to say 8 into 10 to the power 1 means 80 around 80 number of the codes you will be able to generate for small m equal to 12. Whereas, for small m is equal to 10, you will be able to generate far larger number of the codes, already more than 100 number of the codes, almost close to the 1000 we are here. So, with 10 value of the order, we can generate around 1000 gold codes. So, that is if I check the availability. So, gold codes are no other codes are even comparable in terms of the number of the codes available is compared to gold. Kasami actually initially for lower number of the orders, Kasami codes are availability of the Kasami codes are more, but if you are crossing the degree 8, the Kasami codes are, the availability is heavily decreasing compared to my M sequence. So, in terms of the number of the codes available, gold is the winner, and ML sequence is loser in terms of the when the polynomial degree is increasing. Let us come to the peak cross correlation comparison. Again the comparison will be in between 3 codes, M sequence, gold and the Kasami. See, for the M sequence, we understand that it decreases, the cross correlation peak value decreases when the polynomial degree is up to the 6, and then it becomes a constant value always, and even if you are increasing the number of the orders. So, here actually if I compare the both, so M sequence with the higher orders, only the number of the available of the codes little bit increases, but beyond 6 actually availability also decreases, and the peak cross correlation value is also becoming constant. There is no further improvement, which is not a favorable situation and satisfactory situation for a multi-user environment to choose this code for this kind, for CDMA kind of applications. And hence come to the gold codes. Gold is showing us a continuous decrement of the cross correlation values with the increment of the polynomial degree as expected, because it has a 3 different set of the cross correlation peak values. But see the Kasami is even lower, and always actually with the increase of the polynomial degree there is a gap of around here it will be approximately 7 or 8 into 10 to the power minus 1. So, and from there it is the peak value is like that, and here we are having several times lower at the same polynomial degree, and that gap is continuing. It is continuing the degree, this continuing with the increase of the degree. So, the peak cross correlation values in terms of that, if I compare, so peak cross correlation is the best in terms of in the Kasami codes, but if I check the availability of the Kasami code, so with the increment of the 12 order number 12, your heavy decrement in the cross correlation value is possible, but at the same time the number of the codes that is available hardly will be your 2 into 20 or 30 like that, it will be hardly 20-25 number of the codes available. So, the if I am very heavily interested to give address a multi-user scenario, once again I am coming back where actually this very good cross correlation property is required. So, for such scenario, though the cross correlation property has heavily decreased, but there is because of the unavailability of the sufficient number of the Kasami codes for a dense network, we cannot actually provide this code for the multi-user environment. So, finally, again we understand that the gold is not Kasami is superior than gold, gold is not having that much good cross correlation property, but finally gold wins the situation because the number of the cores available here is much more. So, in practical environment where the dense network needs to be designed, gold will be the first choice because of the large number of availability of the cores and pretty good and pretty reasonable amount of the low cross correlation values available. But if your density is not that much higher and you have very few number of the users turned on at a particular time, then you can utilize also the Kasami code, but that will be a choice, it is a variable choice depending upon your system requirement. If your cross correlation values are really very important to go ahead with, then you do a compromise between the choice of the Kasami codes and not supporting large number of the users. But if large number of users is the first choice of the support, then you please go ahead with the gold code with compromise of the larger amount of the interference coming from the in between the codes and handle that interference, that is a code interference. So, intercode interference, you handle that interference by some other means and by some other signal processing algorithms in the receiver.